Lesson 5-6, the Pythagorean Theorem. The Pythagorean Theorem takes its name from the ancient Greek mathematician Pythagoras, who was the first to offer proof of the theorem, perhaps. People had noticed the special relationship between the sides of a right triangle long before Pythagoras. Ancient clay tablets from Babylonia indicate that the Babylonians in the 2nd millennium BC, so 1,000 years before Pythagoras, had rules for generating Pythagorean triples and understood the relationship between the sides of the right triangle. A Chinese astronomical and mathematical treatise called, well, I can't pronounce that, but the arithmetical classic of the Gnomon and the circular paths of heaven possibly predated Pythagoras and gave a geometrical demonstration of the Pythagorean theorem. So while Pythagoras gets credit for the Pythagorean theorem, he was not the first person to come up with the theorem. Ancient Indian mathematicians also knew the Pythagorean theorem and discussed it in the context of strict requirements for the orientation, shape, and area of altars for religious purposes. It was also suggested that the ancient Mayas used variations of the Pythagorean triples in their long count calendar, so that Mayan calendar that, had predicted the end of the world. The Pythagorean theorem tells us about the relationships between the lengths of the sides of the right triangle. The formula for the Pythagorean theorem is a squared plus b squared equals c squared. In the formula, A and B are the legs of the right triangle, and C is the hypotenuse, which is the longest side of a right triangle and can be found across from the right angle. The legs are A or B, which is A and which is B does not matter, and the hypotenuse is C. That one always has to be C. There are several proofs that the formula is true. We're just going to accept that it's true, though, and learn how to use it. We can use the formula to solve for the missing side of a right triangle. So, for example, if I have this right triangle, and I know two of the sides, I can find the third. So I call the legs A and B. Again, it doesn't matter which. I could have called this one B and this one A. If I move across from the right angle, the longest side is the hypotenuse. That's C. My formula is a squared plus b squared equals c squared. I don't know A. I do know B. B is 9, and C is 15. Now I square those. 9 squared is 81. 15 squared is 225. I subtract 81 from both sides. And I'm going to get that A squared is equal to 144. I need to know what A is, though, so I take the square root of both sides. So I take the square root of each side, and A is 12. Here I have some more triangles with missing sides. Across from the right angle is the hypotenuse C, so these are A and B. So I have A squared plus B squared equals C squared. So 1.5 squared plus 8 squared equals C squared. 1.5 squared is 2.25. 8 squared is 64. 64 and 2.25 is 66.25. I take the square root of both sides. And I have that C is approximately equal to 8.14. Here I have C and one leg, I'll call that B. So I have A squared plus B squared is equal to C squared. A squared plus 12 squared is equal to 17 squared. A squared plus 144 is equal to 17 squared, which is 289. Subtract 144 from both sides. And I get that a squared is 145. I take the square root of both sides. And since I know that 144, the square root of 144 is 12, I know that this is going to be pretty close to 12. And it is 12.04. Okay, again I have C. Call these A and B, it doesn't matter which. A squared plus B squared equals C squared. 4 squared plus 11 squared is, catch yourself if you do that. B squared is 11 squared. 16 plus B squared is 121. Subtract 16 from both sides. 121 minus 16 is 105. Take the square root of both sides. And B's 10.25. Why don't you go ahead and pause the video and try this triangle on your own. And then when you're done, unpause the video and see how you did. Okay, I got that the hypotenuse should be right around 24.6. So check your work and see how you did.